The 100-meter sprint has always been a highly anticipated event in the track world since its debut in 1896 for male athletes. Nowadays, spectators can pay upward of $1,100 for a ticket to this event in the Olympics, drawn by the high-action, most intense 9.8 seconds that these athletes will ever experience. The goal of the race is simple: cross the finish line in as fast as possible, while staying in your own respective lane and reacting to the starting gun in less than 0.1000 seconds. There are many physics-related components that influence the outcome of a race and result in the minuscule difference between first and last.
What a start! The goal first time, and Ben Johnson got a brilliant shot. It's Johnson away and clear. Joe gets it low. It's Ben Johnson. Ben Johnson does it again. Unbelievable! The world record is gone again.
At the beginning of a race, athletes are stationary and have no forward velocity. Once pushing off the blocks, the athletes experience forward acceleration, which continues until maximum velocity is reached. In the case of Ben Johnson, he reaches his maximum velocity after 60 meters, which was 12.04 meters per second. This was his world record race, in which he ran the race in 9.79 seconds. In any 100-meter event, there are 3 frames of references: the spectator, the oncoming runner, and the adjacent runner. A spectator viewing Ben Johnson's 100-meter run would see him running at a rate of about 12.04 meters per second, because the spectator is not moving. From Desai Williams' frame of reference, who has a maximum velocity of 11.62 meters per second, he sees Ben running at a 0.42 meters per second velocity due to Ben moving faster at a rate of 12.04 meters per second.
Newton's third law plays a significant role in the 100-meter sprint. When you run, your foot exerts a force on the ground backwards, while the ground exerts an equal and opposite force on your foot, propelling the body forwards. When you run at maximum velocity, due to inertia, the body will not be able to stop all of a sudden, because inertia will cause your body to keep you moving forward. As a result, a mat is a key component to preventing injury, especially after the race when athletes try to slow down. Mats are placed so that athletes can have an inelastic collision. Newton's third law does not only play a role during the race but also at the start, specifically the starter blocks. When the gun goes, athletes push on the blocks and the blocks push the athletes forwards. This allows the sprinters to propel themselves towards the finish line.
When sprinting, energy is released in the forms of thermal and kinetic energy through movement, and sound energy through breathing and foot strike. As you can see, the law of conservation of energy is upheld when kinetic energy is conserved by being converted into thermal and sound energy. Mondo tracks have a harder surface, which enables a more elastic collision to occur when the foot hits the track, returning more energy to the sprinter. Track spikes are a crucial part of a sprinter's performance because they affect a sprinter's efficiency. They are designed to be light by reducing the amount of material used in making the spike. By keeping the spike plate very rigid, the efficiency of energy transfer of each stride is maximized, ultimately improving race times.
Based on this investigation, you can now see that the physics-related concepts, including kinematics, kinetics, and energy, play a vital role in the success of sprinters. We hope that you've enjoyed this video and will begin to appreciate the science of sprinting as the 2016 Olympics approach.
Thank you for choosing
Bill Crothers.
We hope you enjoy the flight.